Good afternoon, Calc 1 gang. I'm going to finish up Chapter 4. Here we go. So this is the material that you'll need to do homework 23. All right, so we're going to name what we ended the last lecture with. We're going to call a function big F of x an antiderivative of little f of x on an interval I if the derivative of big F is little f for all x on I. All right, so let's just quickly see an example before we read any more. So for example, an antiderivative of 2x would be x squared because the derivative of x squared is 2x. So we're going backwards. The antiderivative, not the, because there's more than one, an antiderivative of 2x is x squared. Okay, so given an antiderivative, we're going to call f of x plus c, big F plus c, the general antiderivative. I guess I spelled it right, but it's kind of hard to read. The general antiderivative of little f on I. And here, c is an arbitrary constant. And so we saw this last time in our the last part of our video. If two functions have the same derivative, they're only off by a constant. Same constant c here. And so the question is, what does this c actually mean graphically? What is it doing? And so I wanted to show you, let's suppose that this is our function. That's one of our antiderivatives. And then I'm going to just paste some different copies here. And I want you to think about, as I'm pasting them, you should be thinking about how are their formulas different. I'm just taking the first one and I'm shifting it up or down as you like. We can put one down here if you want to. All right? So how do you shift a function up or down? If you've forgotten that, why don't you pause this video and Google it real quick. Look up function transformations vertical shifts. Well, you shift a function up and down by adding or subtracting a constant to the outside. And so this plus c is just, it's quite literally representing the fact that you can shift this curve up or down, and all of these curves have the same derivative. Look, the slope of the tangent line, if we draw one here, it's the same on all of them. They all have the same derivative. Where you position this thing doesn't matter. And so the most general antiderivative is when you leave a plus c. And what I want you to realize is if we ask for an antiderivative, I did not mean to erase that. An antiderivative is a function. An antiderivative of 2x is x squared. If I ask for a general antiderivative, then it's not just a function anymore, it's a family of functions, right? It's a family because I get infinitely many functions, x squared plus 1, x squared plus pi, x squared minus a billion, x squared plus e. All of those functions are antiderivatives of 2x. And so we write the general antiderivative with the plus c, indicating that you can put any constant you want out there. And what we're saying is any antiderivative of 2x will be of this form. And now we understand graphically that all of these curves, regardless of what you pick for c, all of these curves have the same derivative. Okay, so let's do some examples. Let's find the general antiderivative of, we'll start with sine x. And so we think about it. A lot of times you take the derivative and figure out how to go backwards from that. So we know the derivative of sine is cosine. And better yet, we know the derivative of cosine is minus sine. That's close. So how about big F of x equals minus cosine of x plus c? Check. How do you check these? You compute big F prime. And I get the derivative of minus cosine is minus sine, which is sine of x. The derivative of c, is a constant c, is just 0. So you can always check if you found the antiderivative by taking its derivative, and you should get that. What about x to the n? Here, I'm going to assume n is not equal to -1. So I want to undo the power rule. So usually we go n x to the n minus 1. So if I want to go backwards, I'm going to go, big F of x. I'm going to say big F of x is x to the n plus 1, add 1, and then I'm going to divide by that. And you can see now why I don't want n to be negative 1. Otherwise, I'd be dividing by 0. So we'll slap on a plus c there. Just to make sure we're crystal clear, if I have g of x is x to the 7th, then its general antiderivative would be x to the 8th over 8th plus c. And again, you can pick 0 for c or 1 for c or whatever you want. All right, so let's stop this video here, and then we'll go on to another problem in the next one.